Hi everyone, good morning. Thanks for coming here today. If you're here to see cross-cutting topics about GIS visualization, then you are in the right place. So no one's making for the exit, so that's good. We have three speakers lined up today. So we'll start off with Kyle Titlow with BTS. He'll be sharing some transportation profiles. And then Mackenzie Bartek was unfortunately not able to come due to some medical concerns. She's my colleague, so you're stuck with me. I'll present for Mackenzie today on an active transportation plan repository. And then Eric Dasmalchi with Caltrans will be here as well, speaking on visualizing California bus speeds. So I'm going to go ahead and introduce Kyle, our first speaker. Kyle Titlow is a spatial statistician out of the Office of Spatial Analysis and Visualization in the Bureau of Transportation Statistics with US DOT. He aids the BTS with projects that rely on spatial analysis and big data, including the processing of mapping and GPS points from trucks, ships, and airlines. For this particular project that he's presenting today, he worked alongside Mindy Liu and an analyst from the BTS Office of Transportation Analysis and Sotra Vavalikalono, an OSAV contractor, to complete the project discussed in this presentation. So I'll hand it over to you, Kyle.
Thank you. Good morning, everyone. I'm going to be presenting on a new product that we're getting ready to release at BTS, showcasing the transportation infrastructure, socio-demographic variables found in congressional districts and counties across the US. So quick outline here. I'm going to talk about the background since this is a visualization conference, talk to you all about who our anticipated audience was and will be, some of the requested features for the platform. Then I'll go into some of the back-end development, what platform we selected, how the data was prepared. Then I'll go through some of the tool elements, explaining a bit more of our thought process that went into them than necessarily how to point and click and use them. And then some challenges we faced, some of which were very unexpected when it came to dealing with data in congressional districts, and then what our next steps plan to be. So the background of the tool is pretty straightforward. It's an interactive web map for viewing and downloading congressional district and county level statistics. It includes things that are directly related to transportation. So this is counts of infrastructure, miles of railroad, number of bridges in different conditions. But we also included things that are inherently related to transportation that will be of interest to folks that can't be separated from any analysis that's done. So this is basic level stuff: population, race, mode of commute, place of work, as well as other economic indicators on income, jobs, and businesses. And in reality, this tool helps BTS meet a pretty core element of our legislative mandate, and that's to collect, compile, analyze, and publish a comprehensive set of statistics on the national transportation system. And it is our job to make them as readily accessible to the public as possible. And that's exactly what this tool is intended to do. So within that same law, we are charged with creating statistics that speak to federal, state, local governments. Many of you in this room come from this area, as well as metropolitan planning organizations, generic transportation associations, private sector, and the general public. And so I've highlighted in green here some specific people who this tool, within these realms, we know have given interest in having a tool like this. So we get inquiries from congressional staff members who are interested in knowing about what's in their district. We have an election coming up. It's pretty easy to think about why this is something that would matter, as well as to US DOT policy offices who need to know this vis-a-vis setting priorities for policy, what's working, what's not working. And then the general public, folks who want to know, hey, I elected so-and-so 2 years ago, 4 years ago, 10 years ago. What's happened in my district? Have we seen changes over the past amount of time? And so knowing our audience, some of the features we were asked to include in the final tool were the ability to select specific districts or counties, being able to compare across counties or districts, as well as across data vintages and years where possible. It needs to be ease of use for non-technical users, there's a lot in that single bullet. That's the challenge of our whole event this week, is figuring out how to take stuff that we know really well and explain it to people who don't. And as you'll see, there's plenty of elements we've included in this tool to hopefully circumvent that challenge. and also to make it intuitive and make it easy to download data. On the back end, this tool was created using Socrata Citizen Connect and Esri dashboards. These together helped us meet a number of, you'll notice a lot of the features of these tools match up with things that we included in our original goals. We wanted to be able to vividly map and illustrate statistics to customers seeking data points. We wanted it to be something that could facilitate automated, reproducible products and processes. We wanted to provide data in an open format to customers via downloads and APIs. We wanted a platform that was low code. We didn't need somebody with an extensive background in JavaScript to create this for us. We could do it on our own, that are additionally easy to maintain and scale. Preparing the data, kind of following along this trend of automation, we wrote some Python scripts that compiled the data from NTAD, which that's a bit of an acronym there, but the NTAD is the BTS's database of national GIS layers pertaining to transportation, which was necessary in order to calculate a lot of these statistics. But we also made extensive use of census APIs to pull in ACS data, economic census, and you'll see some of those highlighted through the rest of the presentation. And then we uploaded it to Socrata in our open data platform where it currently lives. So I'm going to go through some of the elements here. There's going to be videos playing that show me going through and using them with some test cases, but I'll talk a little bit about what's going on in the videos, but also explain some of the logic that went into the decisions regarding the tool. So the very first one is a tool guide and YouTube video that we created to help with get users started. I think, as I mentioned earlier, the challenge that we often face is we're transportation experts. We know a lot about this. We know the data, we know the geographies, but we don't really know the person who's going to use this, how familiar or fluent they are with how to use an app, where to find their district or county on a map even. Something that seems intuitive to us may be something that's challenging. So we included multiple options here. We have a text bar on the right, which explains how to use it, how to query, how to download, how to save. But we also went and created a YouTube video. This is alongside YouTube videos that we've created for a number of our other products with an explanation how to do everything. So if this is the method that works best for somebody to understand how to use this tool, this is available for them. That's good. Oh, there we go. And the next one is also pretty intuitive, but the map starts at the national level. So starting with the most recent congressional districts. Once a user loads the page, you see a view somewhat like this. It defaults to population, the population within each district, as the default value. So you can see the entirety of the US. We've used a colorblind friendly palette, worked with our cartography staff to ensure that we've selected one. You'll notice that all of these videos are from the congressional district product. The county product looks exactly the same. It interacts in exactly the same way. But while you're looking through the videos here, another element that we decided to highlight was time series. This is especially for those interested in seeing how values have changed across time, especially those that are the result of transportation policies. So in the bottom left corner, there's a slider bar, which allows users to slide back as far as 2014 to see how a particular value has changed across time. Some states, due to various judicial issues, have had to change their districts over this time period. So for those cases where we weren't able to establish continuity across the entirety of our time zone, we decided to gray out those districts. So, and I'll go a bit more into this at the end as to why this is a potentially problematic element of the tool. But so once you've finished exploring the different years across time, the same sliders available for every variable. You can go over to the left there and explore, similarly at the national level, any of the other pre-calculated or pre-provided statistics. So we have demographics, looking at population. We have median income. We have race. As you can kind of see there, when you hover the mouse over any individual variable, you get the source of the data. You also get some critical metadata. So if you want to go and pull it yourself, or you want to see what else is available, go further back in time. We've also have some commuting data. This is from the American Community Survey. We also included businesses and establishments from the economic census. And then we get into the good stuff, in my opinion. We get into our transportation infrastructure. So we have Right now, only a selection of variables, but we've got some stuff related to airports, number of airports within a district, number of bridges, also bridges classified by condition, so poor quality, good quality, fair quality. We also have miles of railroad, and then at the very bottom there we have docks and marinas. And as you might imagine, some of these variables might matter to different districts in different ways. In this case, maritime is going to be of interest to our coastal or riverine districts versus some that may not even touch the coast. And so our goal, we've got 4 or 5 in there right now, and I'll talk about this at the end as well. We'd like to, going forward, make sure we have an even larger coverage of modes, so that way something is relevant to every district that's around. The next step is pretty straightforward. It's just for selecting districts, but also going back to the original point that we don't necessarily know the background of the people who'll be using this tool. So we've got several options built in to select a district that you might want to look at. If you know the name and the number, you can go straight to the search bar at the top, type in the state, type in the district number, and there you go. And we'll zoom in here. This is Missouri 6. So that's one option. A second option, maybe for those who are a bit more map friendly, more confident in exactly where in the US they need to go to look for their district, you can zoom into that same district, make a selection. This is one that's especially challenging for us because our office deals wholly with maps, and this is second nature to a lot of us, but it's not for a lot of people who are coming to use this tool. And so we want to make sure we have other options available for those who maybe just they know the number and that's what they're there to look for. And so the option there on the right in the bar where the instructions were before provides you with another option to track down your tool, your district. The next one is where we start to really get into the meat of the tool. And so we have a couple options available for users to explore statistics beyond just the color bar that they're shown in the map. So in this case, once you've selected a district and you zoom in the right bar there will appear a line graph. And so the line graphs will correspond to whatever variable is currently shown on the map or the collection of variables shown in the map. So if you have a demographic variable selected, the demographic variable shows up on the side. For the variables where we have a full continuity of data across all 6 years, you see a graph indicating how that variable has changed. So has the population gone up, population gone down? For some of these metrics may or may not be directly related to specific policy initiatives that have been taken. So it could be helpful to come in here and see, have the number of higher poor quality bridges in my district changed over the last 6 or 7 years? Have the median income changed? How have these different variables altered across the time? So right now we have a population variable selected in the right. Before we showed how you could change the variable to a different type using on the left there, but you can also do that from the right above the graph. And so one thing to be mindful for with the graphs is that they don't, the y-axis there doesn't start at 0. So you have to be a little careful about looking at the trends there. It may look like there's been a large change, and in fact, the actual unit on the left may not have changed quite as much. And then we get into district or county comparisons. So it's just as much as somebody would want to come to use this tool to see what's going on in their own district or their own county. You can also do this to compare. If you've got similar counties or similar districts somewhere else within your state or within the country that you'd like to see how you compare, you can come and use the tool to do that as well. So just like before, where you would go to select a single district, you could go using either the map or the search bar and select multiple districts for comparison. For this example, I decided to focus on a couple of districts along the Northeast Corridor, focusing in on commuting by transit, since this is one of the parts of the US where we see the highest levels of transit commuting. So you'll see here, the cursor will go across and pick one district from each of the states along the Northeast Corridor, with showing underneath of it a cartographic representation of this variable. Something that I skipped over before, but this is a good example for this, is that some of these variables are just plain count variables. So there's not necessarily an alternate way to present them. But for variables, especially these demographic and economic variables, can also be represented as percentages. And so in this case, underneath the scale, underneath the legend in the bottom right corner, you can change to show the variable as a percent. So initially you see just the pure number of people who are commuting by transit, and then you can flip it over to see the percent of all workers who are traveling by a given mode. We have this available for transit. We also have it for automobile, which is much higher in pretty much the whole rest of the country. Not a surprise to this group. So now that we have all of our districts selected, on the right side, where we had the single graph before showing the trends for one specific district, and it would be the same for a county, we now have all of them. So we have a single black line that highlights how that number is accumulated across all of the districts that are selected. And then underneath of that, we've got 8 or 9 districts here, so it's a bit crowded on there, but you can see relative to one another how they compare in a given variable. So for districts that maybe want to compare how they are against their neighbors or to one that they believe to be similar, this is a really useful tool for that. And so just like before, where you could go on and you could change the variable on the map, you can change the variable again on the right side. And in fact, as you scroll down on the right bar, you get individualized graphs for each of the selected districts. So you've got a couple of options here to work with. In this case, this is a variable that we have for every year, so there's data points for every year. On the last example I'm going to show, we have an example of one where we don't, and so you'll see how that's accommodated. In fact, actually, Pennsylvania is one of the states where we saw districts change in between typical redistricting due to a Supreme Court case, or due to a Pennsylvania Supreme Court case, and so we only put data for the current geography. We didn't include anything for the prior geography, and some of you can already probably begin to imagine why that might be a problem, but we really didn't want to showcase any correlations that were, changes that were due to changes in geography, not due to changes in other reasons. And so our last option is to download the data. And there's 2 main ways to do this. The first I'm going to show here is to download the whole data set at once, a bulk download. This is going to be for your high-powered users who are going to be fluent in working with data outside of the platform. They want to do their own analysis. And there's a link available to that on the bottom left. Go ahead, go back here. So there's a link on the bottom left that allows you to download the entire data set. You can download tabular data pertaining to each district or county, as well as there's a few instances. Didn't show it on this map, but when you zoom into a particularly local level, the bridges and airports, which are 2 of the features highlighted in the table on the left, begin to show up. So those points are also available for download. And so I'll finish here with some of the challenges. So you've seen the app. It's really pretty. The folks who worked on this did an amazing job making this to be, as in my opinion, as user-friendly as we can make it. But there's a lot of steps that took place before we got there, a lot of challenges. And I imagine a lot of folks in this room have dealt with similar challenges to what you see up here. So, and I'm going to go through a few of them. So one was a challenge we faced almost right away was that a lot of web maps rendered poorly at the national level. At being the Bureau of Transportation Statistics at the U.S. Department of Transportation, inherently our products are targeting the entirety of the U.S. And with that comes certain challenges. We're going to have to show data at scales that's larger than oftentimes platforms that might be built for localities or states or smaller geographies. So there was some playing around that went on here in order to find something that rendered well and in a way that was satisfying to us. Another is that statistics, and this is not unique to this platform, but statistics are updated regularly, and we need to be on top of them to make sure that we're updating statistics as they come in. It's obviously a challenge. And seeing how the wide swath of statistics we have, not all of them are updated at the same time. So making sure that whenever each data set is released, that it's updated accordingly is obviously a challenge. And that's kind of with the third point there, irregularly. Not everything is released at the same time. And then on top of that, there are delays. Things are not happening on schedules with the pandemic. So maintaining all of that and ensuring that we always have the most recent data is a big challenge. The district boundaries change, disrupting time series plots. This was not something that I think any of us realized was going to be a problem when we started this. However, there were states, Virginia, Florida, Pennsylvania, where districts change. And in fact, everybody's districts are going to be changing here with this next election. So numbers are not the same. The same district, the one district now will be, the number may move to an entirely different part of the state. And we have to be very careful to ensure that we're not mapping a current District 6 to the previous District 6, because one of them could be in an urban area, one of them could be in a rural area. And we're going to see very different miles of railroad between the two. And if you don't know any better, it may look like a very clever congressman who knows could come in here and say, hey, I added a lot of railroad in last semester. It's like, well, no, your district got moved around and we added this new railroad terminal in here. But it's something that we need to be careful of. So some of the districts, some of the statistics aren't quite as important in this realm. The population numbers are more or less the same, are going to be more or less similar across vintages, but some of the infrastructure values we had to be very careful about. And so in that case, we decided where there was a change to wholly gray out and not even show those old districts, because we didn't even want to introduce the possibility of showing relationships that we just know are not valid. And then lastly, and this was another issue that we came across that we didn't really expect, and that was that a lot of non-census statistics are not pre-calculated for the congressional district. There's a lot that are calculated. It's really easy to come across products that say how many bridges are in a county or how many airports are in a county. Something like that is a bit easier to come by. But very few products pre-calculate the districts, probably because of these changes that we've discovered, and these other agencies who've been doing this for a long time have realized the same conundrum, and it's kind of difficult at any given time to join congressional districts if they're changing so rapidly. And the continuity across time. With counties, once you go back far enough, you begin to see some of the same issues, but the districts are changing much more frequently. So that we need to make sure, and in doing that we discovered other issues that resulted from that. We've, for instance, realized that depending on how you project your map layers within a GIS, the numbers may or may not add up, and we may see different values depending on slightly which projection you use, which gets into other kinds of trickery that, if you guessed it, politicians weren't aware was something that they could do. If you reproject anything, you can make it seem like you have as many or a few miles of anything you want. We don't want that. So this resulted in some interesting questions of, how do we prepare data in a way that ensures that it's transparent but not leading people to make misleading conclusions. And so our final steps, the tool's not yet released to the public. We hope to have it out of the door sometime this fall. And then moving beyond that, we'd love to expand this to other geographies. Have a similar tool for the states, but also look potentially at urban areas, MSAs, other geographic units that would be of interest to our target audiences. And then looking beyond that, you've probably noticed there's a couple modes of data that are modes of transportation that aren't even shown in the map. And certainly not done for lack of consideration, but we'd like to expand it further, perhaps bringing in highways, ferries, or transit for some of our other data sets that we have at our disposal. Other modal data sets for the modes we already have, looking at passenger employments, cargo employments at airports, highway fatalities, for example, and then we have whole other data sets that we haven't even touched yet that we'd like to get into. So I've got some links here at the bottom to some of the other kind of GIS-related tools, and you can find a lot of the other BTS map products at these links. We have the National Transportation Atlas Database, which I referred to earlier by its acronym, but this is where you can find some of the GIS layers that we use to create this tool. And then I've got my contact information there at the bottom. Thank you.
Questions for Kyle?
Yes.
So are you planning any data completion type stuff for when the boundaries do change, or have you made, because
Yeah.
obviously they are going to be changing, so are you going to be calculating them onto the 2010 versus the 2020 and show both, or do you have?
I don't think we know yet. It's a very valid question, and we're kind of grappling with how to handle it as well. I think we discovered, for instance, that even with the current ones, that we would take existing data sets and cut them up, clip them by these boundaries, and then re-add them up together, and they wouldn't exactly add up, and we'd find odd discrepancies and just by let alone the gerrymandering that produces some really funky, strange shapes that are even stranger when you begin to look at what's happening within inside them. And oftentimes transportation is used as the means of gerrymandering some of those districts. So things get split between districts. And that's a long way to say we don't know yet. And it's a problem that we run up against whether we feel comfortable enough making assumptions about statistical assumptions that would go into that, and whether we're comfortable making them as a statistical agency, and whether it runs up against some of the kind of assumptions that we generally have all of our other products stick to, if that makes sense. All right. Cool. Sure.
Whew, worked. So Mackenzie Bartek is up next on the agenda, and she wasn't able to make it today due to some medical issues, so I'll be presenting for her. But Mackenzie has a journalism background. She graduated from the University of Nebraska, and then she worked with Nebraska DOT as their communications specialist for about 5 years, and then recently joined High Street Consulting and works on a team with me. And she did a pretty interesting project for the Texas Department of Transportation, which we'll get into. Before I do that, I did want to just put out a note too for something that the AED 80 committee is doing. So we have a quarterly newsletter that goes out to our friends of the committee as well as members, and you can sign up on our Google group here. I have the link up there, and you can opt in. Just by joining the group, you will receive this. And it's a roundup of 3 to 4 different events that have happened within the past quarter. It goes out once a quarter. And so we have a sample screenshot up there, but we try to do kind of a span of federal, state, as well as regional happenings in the world of transportation visualization. So back to the active transportation inventory. So we'll go through some of the needs, kind of why was this created in the first place? What is it? Then we'll go through the development process, and then the tool structure, and hopefully a live demo. We'll see how it goes, just with the internet connection. So this is an interesting project. It was really kind of started at a grassroots request that was fed up to Texas DOT. Feedback of kind of, we want a platform to coordinate with each other. We want a platform to know what our neighbors are doing who have planning boundaries that overlap with us. And so that's kind of where this came out of. So this is a centralized location where people can upload their active transportation plans and then see the boundary, the planning boundary as well. So it is, it's Esri-based platform where you can see the planning boundary as well as the plan that has been uploaded and some basic information about it, as well as who to contact about it. So the project goals were to provide a centralized inventory of active transportation plans across Texas, to enable easy access to the active transportation plans, both by engineers and planners as well as the public, to increase collaboration and coordination among planning professionals, and to facilitate the development of safe bicycle and pedestrian networks. The development process for this I mentioned that this was kind of started at more of a kind of a grassroots request, a regional level request for better collaboration, and the process used to develop the tool reflects that. There's a lot of user testing that was done. Myself, as a consultant, when I'm taking on a project and the person that I'm working with is not an end user of that tool, that's always like not a super comfortable position to be in. Because I'm not hearing from the person who's going to be using the tool. And so it's kind of me and this kind of middle person to guessing in some ways. And so it's really nice that they were able to do some test groups and user groups throughout the development of this. So they created some mock-ups with Texas DOT. Texas DOT also has a bicycle and pedestrian advisory group that they worked with. We then had a pilot region in the Austin district where several advocacy groups and the MPO and city level planning staff were able to kind of do some tests and provide some feedback, which is awesome. There is a 17-member advisory group comprised of MPOs, local governments, and TxDOT districts as well. And so they tested the process of submitting their plans and made some recommendations and then supported outreach. Outreach is a big part of this because having a repository of active transportation plans only works insofar as people are actually uploading their plans. So this was a big part of it. The pilot region in the Austin district targeted stakeholders in the pilot region to test an early version of the plan submission portal and what information might be useful to collect about the plans. And then TxDOT also tested the management portal. They're trying to keep track of how often are they being uploaded, and also content. How can they support at a statewide level what the regions are doing. The initial concept of the repository is shown on the screen. It has information about plans that are uploaded on the left that can be searched and clicked on for more information. And then initially they had circles with information about how many plans are overlapping at a certain region. And the end result kind of here on the screen shows the actual space. And so it's interesting because as someone who's an outsider, I'm not an end user, I found this to be a little bit cleaner. It's like, oh, well, it's just a nice number there of how many plans have been uploaded. But I'm not an end user, and that the end users wanted to see right away was, well, I actually just want to see the planning boundary. I want to see like the street of like where who do I need to coordinate with and where. And so these are the kinds of things that you don't always fully appreciate when you're not, you're supporting development from an outside perspective. And so there's the district level, TxDOT district level, counties, cities, MPOs, and then other. So the back end of the tool, this is a Esri-based, ArcGIS-based tool. So there's a set of 3 single-page applications that work together. Esri JavaScript libraries and resources are used for the displays, and then this is run within TxDOT's ArcGIS Online. This is not a software as a service insofar as they're already subscribed to the ArcGIS and Esri environment. And it's out in the wild now. They have launched it and taken ownership of it, and that's great. There's 3 parts to the active transportation plan inventory. There's the plan submission portal, where planning entities submit information about the active transportation plans to be included in the Plan Hub. There's the plan management portal, where TxDOT reviews and improves the submitted plan information. It's like, hey, you accidentally uploaded like a Christmas photo instead of the plan, just things like that, checking to make sure everything's in order there. And then the Plan Hub, this is where users browse the map-based information and the repository of the active transportation plans across Texas. The plan submission portal is public facing. So we'll kind of do a demo, but you can see where information is submitted, which does kind of make it a little bit more important to monitor. So I'll try to go ahead to the web page here. And this is public. You're welcome to take a visit. It's maps.txdot.gov/active transportation plan inventory. You can also just Google tx.active transportation plan inventory, and it will pop up for you, no problem. So there's some sliders here. Sometimes we'll make user guides as we're developing tools, and we didn't want to create like a 20-page user guide. We wanted to just try to have everything in the tool so that you can look at it. We wanted something that people would actually read, which is important. So there's some information here about how you can search and filter within the tool. You can click on the menu here to get some more information. So we'll just try typing a search, because this is how I would start if I was a user. Say I'm in Austin and I want to see what pops up, and I can see the City of Austin Urban Trails Master Plan. And when you click on it, some information comes up about the plan, when it was created, who created it, what some of the goals are for it. And then there's information to, if you want to get more information, they have a link here to the Austin City maps, where they have also a link to the plan website. And it kind of comes up with a visual here. If you were to just kind of start from the beginning, I'll go through the map phase as well. The map section, which is taking up the largest portion of it here. So right now I'm in the Fort Worth area. And you can click on an area and it'll pop up with the 3 active transportation plans that overlap within this region, which saves a lot of time and takes a lot of guesswork out of kind of who's up to what, in the Dallas-Fort Worth region. The North Central Texas COG has their pedestrian safety action plan. And so this has been really valuable for planners. Again, because they were involved in the development process too, and there was ongoing outreach, it's been successful in terms of actually getting people to upload their plans. And so I did want to also mention too, when you kind of have a drop down here, you can go to submit a plan. And then it provides you with some instruction about how to go about the submission. So what you do is you'll actually draw within the map where your region is, and then you can upload the plan information. And so I'll say, okay, I read that. And then you can zoom in to the area that you want to, I won't actually submit it so that the folks at TxDOT aren't getting a nonsense entry from me today. But you can go in and you can see the county level information here, and kind of it'll support you with drawing your plan and providing a submission. So I wanted to just, with that, say thank you and ask if there's any questions about the active transportation plan inventory. Justin, go ahead.
Yeah, just a question. You showed that there for the Austin example, there was a link to their arrest service.
Mm-hmm.
Have you added that any of that information to this as well, or is there a process for that beyond just the sort of plan description and boundary? Is there other data that's being submitted?
There's not other data being submitted about the content of the plans or kind of the projects that they might be trying to have come out of that. I do actually think that would be a very fascinating next step, though, to have actual, if the planning agency already has kind of their planned outcomes, planned line work of what they're looking to do. That would be really fascinating to compile. But it is currently just links to further information outside of the tool. Cyrus, go ahead.
On the submission portal, you said people could draw the boundary of their plan. Is that like literally drawing on this, like, you know, the polygon on the screen, or can you upload an existing boundary?
It is actually working within this interface here. Yeah, it's not. They don't have to upload additional line work or polygons. So that's, yeah, it's been really nice. Go ahead.
So you had said that outreach was critical because it requires people to local agencies to actually upload their projects.
Mm-hmm.
Do you know if there's anything in the works to maybe make it mandatory for through state law or something for the local governments to upload their projects into this?
They're leveraging soft power appeal to the groups. So far, everyone seems pretty receptive to wanting to have a successful holistic region, working together as a whole. I think that's why a lot of people get into planning. But no, there's not any mention of trying to make it an official regulation or something. Just lots of reminders throughout their regular communication with districts and MPOs. Eric, yeah.
I'm curious, do you know kind of how TxDOT articulated the need for this portal and sort of what it will enable them to do at the state level now that they're collecting all these plans through this interface?
Yeah, this was originated out of requests coming from region planning offices. But at the statewide level, they're interested in trying to track what other goals are. And also they have, I presented yesterday on the statewide bicycle network, the really big 8,000 mile bike network that the state is trying to get pushed. And so they also want to kind of be like, are people helping with that? How is that coming along? But it's really primarily intended to also support the regions as well. And then make sure that at the statewide level, they do issue transportation alternatives funds for areas outside of MPOs. And so trying to just have goal alignment as they're issuing that program with what the regions and districts are trying to focus on. Okay. Well, thank you all. I'm now going to introduce Eric Dasmalchi, who is a research data analyst at Caltrans on the California Integrated Travel Project team. He's a native of the San Francisco Bay Area. He's a recent graduate of the Masters of Urban and Regional Planning program at the UCLA Luskin School of Public Affairs. Eric is passionate about public transit and specifically the potential to use data analysis and visualization to support decisions that will improve the transit rider experience and make progress towards climate and equity goals. He currently resides in Los Angeles, California. So welcome, Eric. If you push the arrows, it should work for you.
Thanks so much.
Thank you.
All right, thanks so much, Brittany, for that lovely introduction. Good morning. Let's talk about the bus. So, yeah, as Brittany mentioned, I'm on the CalITP, or California Integrated Travel Project team at Caltrans. We're a relatively small team, only about 10 people at the state, working to
broadly kind of take a new look at the transit rider experience throughout California, understand sort of how our transit network provides an experience to the rider throughout the entire state, even though it's delivered at the local level by 200 plus individual transit agencies. So part of our vision is, just like if you get on a state highway anywhere in California, or to some extent anywhere in the U.S., you kind of know what to expect. We want that to be the same for transit, and it's not currently the case, and we're leveraging various means to get there. So we're guided by sort of principles of rider experience, sustainability, with transportation being kind of key to California's climate goals, and also really the area that's kind of presented the biggest challenge and the least progress. And of course, equity, understanding that kind of everyone, no matter what their means, should have the access that they need to get around, to access jobs, to access opportunities, to go see friends, and do all the other amazing things that there are to do in the great state of California. So a few of the ways we're doing that is first focusing on rider information. So perhaps you've heard of GTFS, or the General Transit Feed Specification. So that's the data standard that was way back in the day developed by Google and TriMet in Portland, Oregon. And that's the data standard that actually almost every transit agency publishes their feed in. And then when you go to plan a transit trip on your phone in Google Maps, Apple Maps, Transit app, whatever you use, it's that GTFS data that kind of allows you to do that. So one of the things we do is we go around and make sure agencies throughout California are publishing GTFS data, that they're on the map, that riders can discover them, and also kind of make sure the data quality is good and support them in achieving that. The second thing is we want to make it a lot easier to pay for transit, which can often be a big barrier to ridership. If you have to have exact change, if you don't know what it's going to cost, if you don't know what the fare rules are, if you wake up in LA and maybe you have the tap card down there, but then you go to San Francisco and now you need a different card. Now you need the Clipper card. How does that system work? San Diego, you have to sign up for an app. From what I've heard, it's a long process. So we think it should be as easy to pay for transit as it is to pay for a cup of coffee. And really the way we can achieve that is through transit vehicles accepting open loop contactless payments with credit and debit cards, just like you'd pay for anything else. And that also gives us the opportunity to automate transit rider discounts. So we're starting with senior discounts, but right now we're rolling out a platform where if you're over 65, you can sign up once for your discount across California, and then any agency that supports open loop contactless payments in the state can automatically give you your discount, which is actually pretty cool, and I think one of the first implementations in the world. So not every agency in California has achieved this quite yet. We're definitely still figuring out how we can make it happen, how we can support it. But one place you can experience this today is the beautiful Monterey Bay area with Monterey Salinas Transit. So not only can you tap to pay with your credit and debit card, but older adults do now receive their discount on their normal credit and debit card when they ride MST. And perhaps most excitingly for this audience, sort of this work in these master service agreements that we've negotiated for some of the hardware and software to make that happen are actually not just available in California. They're available to any transit agency in the US. So if you or a loved one is a transit agency that wants a modern payment system and other cool technology at an attractive rate with procurement largely figured out, definitely check out our California Mobility Marketplace, or MobiMart as we like to call it. I think new this week, it now also includes contracts for cellular connectivity through FirstNet, the network used by first responders, now at a good rate for transit providers, especially in rural areas where they might not have really good connectivity to push that real-time data out from the buses. We're trying to solve that too. I think our first out-of-state implementation was actually in South Carolina. They leveraged our MSAs to accept open-loop contactless payments on their buses for a transit agency called, I think, Coast RTA on the SC Coast. So yeah, I just want to tell you a little bit about who we are, what we're up to. But to move towards the analysis and visualization side, the main reason we're pushing all these kind of open data standards and providing the support is for the rider, right? For the rider to have accurate trip planning information. But as it happens, that kind of same information that powers trip planning for the rider, that lets you know when your bus is coming, we can actually collect that, and it creates this sort of really kind of rich, warehouse of data for us to analyze. And it's a little overwhelming, and it's a little hard to figure out sometimes. And so we're really just kind of scratching the surface on what we can do with analytics. But now, not only is it possible for us to understand sort of the geography of transit in California, where the routes are, where the stops are, but in archiving that real-time data, which in this case is vehicle positions updates that come out about every 20 seconds, we can save that over time. And now we can look back in time and understand the actual performance of transit in California. Did that bus show up on time? How long did it take to get from here to there? The GTFS real-time spec has a few major components. One is trip updates, sort of that when you can expect the bus, positions of course, and finally service alerts, which is kind of more descriptive, but stuff, explaining kind of detours and other unexpected things to the transit rider. So why are we focusing on the bus? Turns out buses are super important. The vast majority of public transit in California is, delivered by bus, and transit is, so essential to our goals in expanding and improving the multimodal network, in leading in climate action, in advancing safety on our roadways, and in advancing equity. We have sort of all this great legislative direction, all these kind of commitments to a reduction in vehicle miles traveled, to reductions in greenhouse gas emissions, and yet, we've kind of had a hard time actually making that happen in transportation. I think part of that, kind of calls back to that transit rider experience and refocusing on delivering good service and what it takes to make transit, something that people understand is available in their community and something that works for them. And so we're hoping to get there. But just to show that kind of worrying trend a little bit more, we've been in a period of actually declining ridership in public transportation in the US, but actually especially so in California. And this was true before the pandemic. This graph doesn't even go towards COVID. And, in most of the state in these years, investment in transit in terms of kind of dollars to run service was actually going up, or we're building new rail lines. And yet we're seeing those declines. So it's really important to me, and it's really important to us at Caltrans that we sort of understand what's going on and offer the support we can to turn that around. So from there, we kind of first started focusing on bus speeds. If you ride a bus and it's going very slowly, that might be a frustrating experience when you're on the vehicle. But another thing that's kind of important to understand is if the bus is going slowly, that's kind of, and transit operators have, a certain amount of resources to put service out there, a certain number of operators, a certain number of vehicles. And if those vehicles and operators are stuck in kind of crippling congestion, then, they can't get to the end of the route soon enough, they can't turn around, they can't serve the next route, they can't kind of maintain the same frequency because they're getting stuck in traffic. So, either you need to find more resources just to run service that feels the same as before, or those slow speeds actually erode the frequency of the transit service. And, besides speed, frequency is also extremely important to the rider experience. There's research that shows that time spent waiting for a bus actually feels worse than time spent being on the bus. So how can we get more people on the bus and less people waiting? Now that we have sort of all this rich data from GTFS real-time vehicle positions, we started making these California transit speed maps. So in this screenshot, you can see these segments went with kind of a simple red, yellow, green color scheme that maybe I should reevaluate after the keynote session from earlier today, but thought it speaks to some normative value perhaps. Red is bad, red means stop, green is go. We want people to be going. This is kind of just based on sort of reasonable speeds for urban transit. So the greens kind of get into the 18 to 20 mile an hour range. And then if you see those deep reds, that's, a walking pace bus, 3 miles an hour. So continue a little bit. We built these maps, with kind of this really iterative approach, which was also fun to figure out. So we have consultants that kind of help us build out the data infrastructure of the warehouse, the sort of the computing that actually goes out and kind of fetches data from all those transit agency feeds every 20 seconds and catalogs it. But the analysis and the visualization side of this, we actually did largely in-house at Caltrans, starting almost a year ago, and starting really small. Can we map one route? Like, what did the speeds look like for this one trip? And then, we'd take that out and we'd get feedback from transit agencies from other parts of Caltrans and, use that to continue to develop. So in the middle, okay, now we can map out a bunch of routes. This is on the peninsula, just south of San Francisco. But if you just map those kind of basic route geometries with a little buffer, it kind of looks like every bus is in the middle of the roadway, right? Because, how else would you know? And you can't tell which direction things are going. So in kind of the latest version, we went back, really back to kind of ninth grade geometry. And you're like, well, if we look at each segment and draw a little triangle and cut that out and space them out a little bit and offset it to the right of the road, now you get something that, provides that directional information at a first glance. And, now you can visualize a bus route that goes 2 directions on a street, like most do, without being confused. So once we got there with the maps, we launched our Better Buses Challenge, which we kind of promote heavily throughout Caltrans and also with our partners at transit agencies and local jurisdictions to share those maps that we have available throughout California and really solicit ideas to speed buses up. Because if you see, a splotch of red on a map at an intersection, it's great to know that bus is slow, but we don't, always necessarily know why or what kind of the correct intervention would be to speed those up or kind of what you would pick from that menu of transit improvements to get buses going. So we got a few good ideas from this that we're actively working on and seeing how we can best make happen. We didn't get as many ideas perhaps as we'd liked. So we're also working internally within our team to kind of bolster those recommendations and come up with some on our own. And just to give you a quick look at what some of those recommendations might be, we kind of identified 3 major categories for opportunities to improve bus service in California. One, looking at kind of corridor improvements, or longer corridors, maybe a long segment of a route on a major street where we're experiencing slow speeds, where that might be a good candidate for a bus lane or for kind of a quick build improvements, or maybe in the future a full bus rapid transit project with more of those features like defined stations, level boarding, off-board fare collection, all those things. Or it might be more of a spot improvement. Maybe there's just a couple intersections that is a problem. Or maybe the bus runs on a local arterial, but it crosses a freeway and there's 9 ramps and 2 traffic signals, and that kind of adds a whole bunch of delay. How can we speed up the bus through there? And also portions of the state highway network that have gaps in service, where maybe you can drive directly from here to here in your car and it'll take you half an hour, but if you wanted to get there on transit, you'd have to go kind of all the way south to the nearest town and then back around and up, and that might take 2.5 hours. So we want to provide as much as possible the same level of access throughout California. To give you some examples of what that might look like, here's a corridor in the East Bay area on San Pablo Avenue through Oakland, Emeryville, and Berkeley. So in the afternoon peak, we run, Caltrans does not run, the local agency, AC Transit, runs 40 bus trips through that corridor. That's about a bus every 6 minutes. They've designated it as a rapid corridor. It's a high ridership route. And yet we're seeing speeds below 8 miles an hour on that roadway, which we don't consider to be especially rapid, and we should be doing better. There's a little bit of signal priority, but clearly, we think there's a need to go further, and we can kind of identify this segment as a spot that we should be focusing on for bus lanes, that we should be focusing on for boarding islands, for queue jump signals, for transit signal priority. If you kind of draw a box around this corridor and you say, okay, kind of how much time is lost compared to if the bus was able to average 16 miles an hour, we're losing 32 hours every single day just in these few miles in the East Bay. So that's, not only is that kind of 32 hours across the thousands of riders throughout the day, time that they lose, that's also kind of 32 hours that the transit operator, can't use those buses, those operators, those resources to run more service. So, we've kind of seen a vicious cycle over the years where, bus speeds get worse, service gets worse, more people give up on riding transit, more people start driving, traffic gets worse, bus service gets worse. We want to turn that around. The good news is, you can also have a virtuous cycle. You improve transit service, you speed up transit, you get more riders. More riders, it's a potential for more investment. It's a potential to run more service. And then, all of a sudden the bus is coming every 2 minutes and in a dedicated lane and getting you where you need to go. And so we would like to get towards that vision. Here's another example in the Los Angeles area on Santa Monica Boulevard. These 2 examples, by the way, are actually both directly on the California State Highway Network. So that's somewhere that, even though these are local roadways, they're kind of legacy conventional highway, non-freeway routes that Caltrans does manage and maintain. So we're flagging these for the rest of our organization to try and figure this out. And in fact, here, Caltrans District 7 is already considering bus lanes in this corridor. So it'll be really exciting to use our data and do some before and after evaluation. And then here's what one of those hotspots might look like. This is Sacramento. This is that situation where you have a local street crossing a freeway, and maybe speeds are pretty good, but then through that interchange, it really bogs down. So you can take a fresh look at that. Similar in Santa Barbara. And finally, having this data is pretty new for us at the state level. And it turns out there's kind of lots of other programs for grants or housing-related programs that would like to have kind of better data about transit or kind of custom data products at the more local level. And one of those is we have a grant program called Solutions for Congested Corridors, where applicants, which are normally kind of at the city level or regional level, apply for these grants. There's kind of a whole bunch of technical metrics. But this year, for the first time, level of transit delay is one of those metrics. So it's a little bit of a manual process. Right now, an applicant, unfortunately, we don't have a fancy interface where they can click directly on our map. So they have to come up with the polygon themselves. They send it in to us. But at least once we get it, we can, using our analysis tools, kind of figure out which bus routes run through there, how to measure that delay, get those numbers back to them. And I'll just give a quick demo of the website itself. Cool. So this is our website. This is open to the public. So if you go to analysis.calitp.org, you can navigate to our transit speed maps. We have about 50, and it's organized by Caltrans district. We have at least one in every single district in California, some more than others. D4 in Oakland, San Francisco Bay Area has a lot of operators, as does District 7, Los Angeles. But if I click on one of them, each of these pages has several maps of bus speeds at the morning peak, midday, and afternoon peak to represent a typical day. And it is, the site's interactive in the sense that you can scroll around on it and look at particular areas. You can mouse over and get some information about, which route is it, how frequent is the service, how far down the route early, what are the speeds in this segment, and kind of identify areas of congestion or opportunities to speed things up. So I'll show you one more example in San Diego MTS. Since we've kind of just started collecting this data over the last couple years, kind of projects put in place before that. Unfortunately, we don't have the before data to do a really good kind of before and after evaluation. But now, definitely, as we hear about sort of new bus lanes that are coming in, we're going to get sort of more and more interested in figuring out, what conditions were like for riders before that bus lane, before that project, and what happened afterwards. But actually, San Diego happens to provide a really good natural example here. So a little bit east of downtown, you can see these two corridors. And this lower one, we're seeing speeds around 7 miles an hour for this frequent east-west route. And yet this upper one, we're seeing speeds quite a bit faster, 10 to 16 miles an hour. And actually, this upper route has a bus lane and has some limited BRT features. And this wasn't super expensive to construct. It wasn't a huge capital project. But you can already see that if you can take this one, it's twice as fast as that one. And we're really hoping this data analysis can help achieve more successes like that throughout California. And I'll definitely be taking some of the lessons I've been learning from this conference back and working to make this better. So with that, thank you so much, and happy to take any questions.
This is fantastic. I think when we do GTFS data, we should have a better picture of this speed delay element.
Yeah.
The schedule itself is better than nothing, but provides enough overly optimistic view. So my question is, how many agents, is it difficult to install real-time GTFS? Is it expensive for agencies to have?
Yeah, that's it's an excellent question. It's a big part of what we work on, and the answer is it really depends. So with our 200 transit agencies across California, the resources they have, the kind of realities of how they operate can be wildly different. So you can have large agencies with in-house data teams that understand exactly how GTFS works and exactly what they need. And they probably have a contract with a vendor to actually have that sort of CAD-AVL, computer-aided dispatch, automatic vehicle location hardware on the buses themselves, and sort of the right communications hardware and the right backhaul to get that data back from every individual bus, aggregate it, and then of course publish it in the GTFS real-time open format and out to the riders. And sometimes that goes smoothly, but then you can find agencies where maybe they're kind of locked into a vendor contract where they didn't ask for GTFS RT in the first place, and now the vendor says, well, that's going to be a very expensive change order if you want us to do it, or you'll need kind of different hardware, or they'll kind of, maybe their kind of system is getting old anyway, but they're kind of intimidated by the procurement landscape, or they don't have a lot of time to run a procurement themselves because day to day they're just really focused on the operations of the transit system. It could be a small transit provider in a rural area that only runs several buses and doesn't get a lot of interest from kind of the big vendors that offer these more turnkey solutions. And in that case, at CalITP, we actually did a pilot project with open source software and open source hardware for GTFS real-time on the bus that we would help them set up and provide. So I think a few agencies got to use that, and we took the lessons we learned from that, and we're actually combining it into another statewide procurement. So just like we have those master services agreements for contactless payments and connectivity, we're also working on a procurement for a simple GTFS real-time solution where the contract would be negotiated at the state level and available for streamlined procurement for all those local agencies. And I believe that will be available nationally as well. Yeah.
I think you did talk a little bit about this, but the GTFS real-time data, we have to gather that in real time. It's not archived anywhere.
We gather and archive it ourselves.
You gather yourself.
Yep.
Okay.
Correct. It's Yeah, that one's a heavier lift. Especially as we've been kind of adding more and more agencies, which is good. It means we're being successful. It means we've been helping our transit agencies provide GTF SRT and kind of communicating the value to the rider. But yeah, the more data that we have to archive ourselves every 20 seconds, the more data infrastructure it takes, and the more you have to scale. So that's what we get kind of great support from our data services consultants on. And actually right now we're kind of moving from our version 1, which really has gotten to the point where we can't even kind of jam one more transit agency into it, to a new version that's going to scale a little better for the future. And that, by the way, the code to run that is actually all open source itself. So if you look up CalITP on GitHub, you can see how we do it. Sure. Yes, in the middle.
Yeah, I was curious about, so that I'm not that familiar with GTFS, so I'm assuming you're getting XYs for the locations for the buses, and then that's what you're using to do the routing?
Yeah, that's correct. So those vehicle positions reports come with an XY. They come with a latitude and longitude. Now, of course, it's a GPS ping every 20 seconds, so it's not, that XY is not guaranteed to be like bang on the transit route, in the exact lane that bus is going. It could drift a little bit, it could drift backwards. So there is some data cleaning, data processing on our end. But those XYs from GTFS real-time vehicle positions, in addition to the XY in that kind of position report, it also includes an identifier for which trip it is, and then that identifier can be tied back to the schedule, and then kind of linked back to, okay, which route was this on, which geography does that route traverse. So we do take those XY coordinates, but then we sort of snap them to the route it's expected to be on, and that's why our distance calculations are basically linearly referenced along the route.
Right, great. Sorry, just to follow up on that. So this representation, then, you've created the line work for those routes, and that's where you're doing the snapping. What technology are you using what is this tool?
It's mostly Python, pandas, GeoPandas. We develop a lot in Jupyter notebooks, kind of get that rapid iteration. And this site is actually published from a Jupyter notebook. So this is Jupyter book. It's a parameterized notebook where there's kind of one notebook that's designed to kind of take one transit operator and generate these several maps. And basically the script will chunk through for every operator we have, run that notebook, render it into a static web page, put it on this website, which for the most part works great and enables this pretty streamlined development process, but it does mean, for example, this website is fully static. It's not backed by a server. So when you click around on this maps, this is just because that's embedded in kind of all this static JavaScript, the way the map is rendered. So there's definitely a limit to kind of how much interactivity or kind of customization or aggregations the user can have on this website right now. And especially for our larger transit systems, like our LA Metro, it can make for a pretty slow page load time as this chunks through about 80 megabytes of map in the browser. So we'll be, looking at what we can do with more technologies in the future, but that's how it looks today. Of course. I think we had another question in the back.
Actually, that was my question.
Oh, okay, great. Yeah, go ahead.
So you said do you manually offset the directions for the line, or
Uh-huh.
can you explain that a little bit?
Sure. So that, cool, LA Metro is loading. Yeah, we get ready to see a lot of red. It's a very dense bus route. LA is kind of blessed with actually a pretty good grid. It's a big grid. There's some longer walking distances, but this could be a dream geometry for transit if we could just get our buses out of traffic a little bit. I live in LA, so some of this gets a little personal for me. But yeah, so the way these are offset, this actually ended up being surprisingly elegant in that if you're familiar with the GTFS spec, there's sort of that trip information, which links to route information, which also links to shape information. So that shape from GTFS, in the GTFS format, the shape is actually a series of points that says, this trip started here, then it went here, then it went here, then it went here. And the points kind of trace down the streets. But if you build all those points into a line string, that's an ordered line. So there's still a sense of direction in that line, which is actually really important because Shapely, the spatial processing Python library that we're using, has a really handy function where you can just do kind of a right offset by however much distance. And since the line is directional, that right offset will always offset it to the correct side of the street. Yes, Brittany.
I was just curious, you mentioned the chart you showed earlier that ended around 2018. What has the pandemic done to?
Yeah, I mean, the pandemic really dropped ridership, obviously in the height of COVID when everyone was staying home. I went on a bike ride and, it dropped kind of travel in general quite a bit in the beginning. Went on a bike ride once, and it was like a street that like functions like a busy highway. I saw like kids riding on it on their bicycles, and like like seniors out for a morning stroll. You're like, wow, pandemic is terrible, but this is a very different LA than I'm used to seeing. But yeah, transit ridership, perhaps especially harder hit. There's definitely kind of some public health fears around riding transit, around being in sort of a crowded vehicle with other people and how that feels. Kind of from that really steep drop, we saw eventually a substantial rebound, but it's not quite back to where it was before. And that also depends on the geography of your transit system and who it serves. So in LA, most we have a lot of ridership, but actually most LA Metro riders, tend to be folks who have a hard time accessing a car or a vehicle, whether that's because it's not affordable or maybe they only have a car some of the time. So riders that and they're going kind of all over the regions, and so they do need to travel. So a system like LA Metro, I think they now, at least in bus ridership, have, I think at least like around 3/4 of the riders have actually come back since the pandemic, if you look at today's data. But it's a different story for other transit systems in California, like BART, Bay Area Rapid Transit in the Bay Area, which used to have really high ridership kind of from those East Bay suburbs into downtown San Francisco. A lot of riders being those kind of downtown office workers commuting to jobs where parking is difficult or expensive. And I think there's an open question with kind of how the nature of work is changing and with remote work, whether that sort of traditional peak period, peak direction ridership to and from downtowns is coming back or not.